Thanks, Mike. Thanks for the introduction. Yeah, so I have been working on Scala like it feels like forever probably, because it has been forever, about 10 years now, I think. Started as an intern at EPFL and been working on the compiler basically ever since. So right now I lead the Scala team at Lightbend. And there's a lot of links in the talk. So you can kind of dig in later if you feel like it. There's a link on my GitHub to follow along now or kind of follow up later. So you might know us as TypeSafe, and we still are at heart. But right now that's the name of my employer, Lightbend. And I mean, first off, as Mike said, 2.12.0. I'm super happy to have this out finally. Thanks. I'm sure you are too after a long wait. Thank you all for contributing and for making this happen. I think this is going to be a really cool release. We're very excited about running on Java 8 and making use of all the shiny in there. So we started with a keynote that was basically about contributing to Scala. And I want to start my presentation to again thank everybody and to point out like the large percentage of the work that goes into Scala that is done by a lot of people in this room and around the world. So thank you very much. And I didn't make these round numbers up, by the way. They come from GitHub. I'm just pleased to say it's all powers of 2. And so we're a small team at Lightbend, sadly not a power of 2. And like in reverse chronological order of joining the team, we're very happy to do all that compiler hacking and to work with you, from now on to 2.13 and the next 2.12x releases. We're also very happy to collaborate with the Scala Center and to really let them be the stewards of the community that I don't think a private company can really do. We're very happy to have that Swiss neutral partner to channel all the efforts of everybody that's working with Scala. And of course, we're a member of the board and we contribute to the center and we aim to be the really upstanding members of the community. And I don't say that as a form of like we're detaching. I'm saying that as a form of respect for the process and for the organization that is behind that foundation. So we definitely want to do everything we can to contribute to that, to enable that, and to kind of maybe sit back a little bit and make sure that the community organizes around that. And so the Scala Center plays a very important role on those 3 missions. And so it's a process, and those things are hard to get right, and certainly won't be, gotten right from the start. That's why there's 2 community representatives there that you should talk to, or me, obviously, if you have any thoughts on how to do this better. We're definitely here to learn from everybody's experience in the community. I hear a lot of people, say, wow, Scala 2.12 took 2 years. But we do a Scala release every 6 weeks, which isn't exactly the rate at which companies that own the whole stack can deploy at. But I think it's pretty good for a language and for the small team that we are. And just to kind of give you those data points, in 2015, we did those quarterly milestones for 2.12.0. We got a little bit of a later start than we anticipated because we extended the lifetime of 2.11 development. A lot of the stuff that landed in 2.12 actually landed in 2.11 first, some of it as experimental features, because we're cognizant that not everybody can immediately upgrade to Java 8. Most likely everybody in this room will soon or has already. Maybe we can do a quick show of hands who's still in Java 6 or below. Yeah. Great, but not everybody is as lucky as you guys. So 2.11 has had a good life. The end of life of its development is coming up this year. But 2.12 got started a little bit later because of that commitment to Java 6 that we still have. And then very happy, of course, to have released the 2.12.0 final this quarter. And there will be another .1 release, as always, shortly after the .0 release to fix a couple of bugs. That will happen this month if all goes well. And the last 2.11 release, 2.11.9, is also scheduled for this year. That's not to say we won't ever do another 2.11 release. It's just to say that we haven't planned to do another one. 2017 we'll be focusing on 2.13, and obviously 2.11x minor releases. So let me give you a quick overview of the headline features and some of maybe the kind of cooler, sneaky ones that got in there that you might not be aware of Scala 2.12. After that, I'll dig a little bit into how those are implemented in terms of Java 8 features, and of course conclude with a quick kind of heads up of what's coming in 2.13. But as I said, that's part of what the Scala Center is for and what the process is for to determine what exactly 2.13 will be. So I'm going to give you our intentions and our commitments, but I'm not speaking for what exactly the Scala Center will approve and what we as a community will decide to do. So the shiny, of course, is Java 8. There's a lot of really exciting stuff on the Java 8 platform that we have been for years eager to make use of. And these two features go hand in hand. So finally being able to compile a trait to just one interface instead of an interface with a class that has all the implementations for those methods is a huge boon for, from simplifying the compiler internals to binary compatibility. Sadly, it's kind of proven to be taxing for the VM, so we had to do a lot of work to make sure that we don't kill startup performance, for example, and I'll talk a little bit about that, but I'm not going to go too technical in this talk. But the first thing is that a trait now compiles to an interface with default methods. And that enables the next point, which is a function, which is just a trait in Scala with one abstract method, the apply method, can now also compile to a functional interface on Java. And we basically use the same machinery as Java 8 does to spin up those anonymous subclasses that we used to have to generate at compile time. So SAM stands for single abstract method types, and INDY stands for invoke dynamic. But we like to talk about SAMI and INDY. The other thing, not to be forgotten after all the hype around Java 8, is that we have a new backend and a new optimizer that was a long time coming. A lot of the work started at EPFL. Miguel Garcia did a lot of the early work on this, and both on the backend and the optimizer. I'm very glad to now standardize on an ASM based. So ASM is a library used around the whole Java ecosystem to generate bytecode. So it's very nice to be able to simplify the pipeline at the back end of the compiler and also make it faster in emitting bytecode. And the optimizer, which Lucas on our team took over from Miguel and really turned into a production-ready optimizer that I recommend you give a shot and try it out. Of course, there's binary compatibility consequences for doing so, but it is an optimizer that I think we feel comfortable now recommending you use in production. And so we did a lot of work around testing and adding new optimizations and so on. Lucas has given a couple of really good talks about this recently at Scala World. So I'm just going to refer you to his talks. He can speak to that with much more authority than I can. ScalaDoc, one of those things that we as a compiler and library hacker team never quite find the time to work on, and so we're very grateful for Felix Mulder and Jakub Odecki to have contributed these really cool features for ScalaDoc to make it look nice in this decade instead of the last. And to, for example, allow documenting your Java sources with ScalaDoc now. So I mean that's really cool. For the Rapel, we're now using the same presentation compiler as the IDE and as Enzyme and those other projects that are based on the presentation compiler that's part of the actual Scala compiler. And you may have noticed that tab completion got better at the 2.11.8, I think it was the first time we introduced it, but I wanted to mention it here. And this other sneaky feature that's been there for a while, but that we can't really enable because it might screw up Emacs users and stuff like that. I don't know about VI, but so you can have colored highlighting in the REPL, and we're thinking about how to kind of enable this in a user-friendly, backwards compatible way. But we'll get there. For the library, I mean, this was 2.12 was a compiler release, so we've consciously tried to minimize the impact on the library to facilitate cross-building and to really be able to focus on one important aspect of developing Scala. But there were some important improvements to the library. I would say that the three main ones are that either is now write biased, and CATS, for example, is intending to standardize on that instead of XOR. There's a lot of goodness in this repository. In the second bullet, the Java 8 compatibility layer, dealing with streams, includable futures, or whatever they call it in Java. And a lot of other stuff that 2.11 needs to compile to Java 8 style lambdas, and that are still a nice convenience to have on 2.12. Another thing I just wanted to mention, if you were still counting on filter to be used in the for comprehension, desugaring, well, don't. It's now standardized on with filter. It's just one of those things that has been kind of niggling us forever, and we wanted to deprecate and get rid of it, and I'm glad we did. As I started out by saying, the contributors, ultimately, it's getting close to half of the work. We want you to have the best experience possible, and we're very glad to have type level to channel those efforts in a different organization and to work with, and to kind of keep us on our toes to make sure that we can meet those expectations. And the SBT build is something that you can find on Jira that has been talked about for years and years, and we've always wanted to do. But it's one of those things that just think about, bumping your SBT version, the dread that fills you with. It's just one of those psychological things where you don't feel like doing the work because it's just you don't know when you're going to end. And I spent a lot of time reworking our Ant XML build actually in 2.11 just as a little. This is not recorded, right? To kind of set the scene for the SBT rewrite. So basically we had like an Ant build that was structured like an SBT build, so we could really, I guess you can call us a little paranoid. We don't want to ship a broken Scala release that suddenly is like missing some class files here and there, or is doing like the OSGI manifest all differently. And there's a lot of paper cuts that will kill you before you get to the boss level. But really, really happy to have the SBT build, and Stefan did a lot of the work, our newest team member. And we're reaping the benefits, and we all are, I think. And we're doing our best as engineers to be good communicators as well. Standardizing on platforms like GitHub definitely helps, and having Scala Center and type level and multiple channels to talk to the community is a great boon to all this. And of course, very happy to see new faces on the pull request queue all the time. So I also definitely want to thank the DotE team for a very fruitful collaboration. I think especially for the first bullet here, the trade on Lambda encodings, it went both ways. We learned a lot from them, being able to experiment with less baggage, or maybe no baggage. And our baggage definitely taught them a thing or two about what actual production byte code should look like. So there's a lot of other things that are there that are essentially aligning us with DotE for the longer-term future of the language. I won't go into much details, but I'm happy to take questions later if you're curious. And of course, as now daily users of SBT, the 0.13.13 release, despite its ominous number, is a real nice upgrade. So I recommend you check it out. Actually, speaking of questions, looking at the time, I do probably have time to take live questions, which I usually prefer. Is there anything that you'd like to, interject or ask about at this time? No? Well, then I'm just going to get a little bit more technical and see what happens next. Just a little bit more. So as I said, we're super excited to have Java 8 underneath us now. And I do want to start this little topic by saying that I don't think functional programming is just throwing in lambdas into an existing language. This is great for us because we now have all the tools on the platform. We have the mindset, and we have a lot of Java libraries out there that are starting to think more like Scala programmers. So it's great to have for Scala as a language, without a doubt. I always think of Java 8 as a bit of a gateway drug to Scala. I think once you've tasted the kinds of abstractions that you get there, you'll want more, and we have it. So I think the number one thing that I would mention is isolation, is being able to reason about your code through time. Think about sharing mutable data structures and what that does for program understanding, or being able to distribute your program. And so these are all tools for a means, and the means is to write modern applications that scale out and that are robust and that will that you can't let crash. I'm not going to plug reactive, don't worry. But I do think that there's a lot of good in there, and a lot of that is enabled and is easier to do in Scala, and is kind of natural to do in Scala. Another kind of insidious example is having statements in your language, which makes everything look like a side effect. If you think about expressions as resulting in a value, it's much more natural to think about computations as data, for example, or just as computations in their own right. And similarly, like, maybe these look like conveniences, case classes, and pattern matching, but they shape your thinking and they shape the way that you implement your programs. And structured data is all around us, and being able to make sure that you covered all your cases is, in my opinion, quite important and quite helpful for the compiler to do that. And we don't have the best exhaustivity checker out there, but having implemented, I think it's pretty good. But it definitely can be better, and we're looking at what people in the DotE context are doing there. And even though the collections aren't technically the language, I think of it as part of the language, and I know that a lot of people do. And they were designed functional up by design from the start. So I think that makes a big difference. Although there's a lot of interesting things that we're seeing in Java 8 and that we definitely want to interoperate with and learn from as we go into 2.13 and the collections rewrite of 2.13, or I should say refactoring. And the kind of type inference that we're able to do in Scala may seem like just a benefit of not having to do code generation or not having to have your IDE do this. I don't agree. Code generation is a maintenance liability, and you should use it when nothing else is available. But we have a perfectly good way to infer types and to get rid of that baggage and to be able to refactor and infer, maybe slightly different types, but at least you still know what type checks. So it is really about safety and maintainability at the same time without getting in your way. And I did say that, and I mean it. It's part of a feature of the type system in Scala and a way of thinking that the type checker has your back. And when it does compile, you have a good shot at being right. And I'm not saying you're guaranteed to be right. We're not a proof assistant, and we will never be. A type system is a lightweight way to do verification of your programs, and we certainly don't want to make it into something that becomes unbearable. But having this variance on the definition side really is something that I think is important to drive home here, because just look at what you have to do in Java. And that is a perfectly understandable decision on their part. They couldn't do it any other way because of the backwards compatibility constraints that they had when they introduced generics. And so I'm not bashing Java. It's just their hand was forced here, and they know that. But by having this power at the definition site, you don't enforce this pain, or you don't inflict this pain on your user every time they use your abstraction. And this may seem like a variance. You don't have to understand how it works for it to help you in your daily programming. And I think that's kind of what we try to do with Scala, and we don't always succeed. And sometimes the type system or the compiler does get in your way or in your face with ugly error messages or slow compile times. But ultimately, that's our goal. We want you not to have to worry about bugs that we can worry about at that level. OK, so onto the more technical stuff. Like I already said, the trait now compiles to an interface. That's great for binary compatibility. It's greatly simplified the backend in the compiler not to have two of everything when there was only one in the kind of the conceptual domain of Scala. And it also means that we can now compile function n from 1 to 22. It's still 22 to a SAM type. Yeah, and so this sounds like a magic kind of solution to fit traits into the Java ecosystem. Sadly, it's not. We will need something like class dynamic or something to really get rid of all the niggles, or something like tasty, or I don't know what it will be. But if you have a field in a trait, subclasses of that trait are still going to be recompiled when you change something about that field, when you remove it, when you add another one. When a trait extends a class, an interface in Java can't extend a class. So that's a liability or an obligation for the subclasses downstream to add that class. It's not something that is rendered to the interface on the Java 8 platform. When you have a super call, maybe most surprisingly, that actually gives rise to an abstract method that is a super accessor, because we don't know what the super call is going to be until all the traits are mixed in and we know what the linearization is going to be in the first subclass of that trait. So these are all kind of slight mismatches, and it fits almost just right, but don't be fooled. Traits still come with a penalty when it comes to evolving your APIs. It's substantially less, and at least you can do some of evolution, like you can add a concrete method. You can add a final constant val because it doesn't give rise to a field. It's just a constant that will be inlined everywhere. But it doesn't come for free. Be careful when you change your traits. It's not all of a sudden solved. Question?
Would you say that having a trait extended class is good practice, bad practice?
I mean,
what's your recommendation?
It's hard to say in general, but I would definitely say think twice before. Why are you doing that? Do you really need it? It is a shackle, and so it is it is good practice to avoid it when you can, I would say.
What caveat, what possible problem might you hit if you did that?
Well, so like I said, if you add a class to a trait, all the subclasses need to be changed. If you add a trait superclass to a trait, the subclasses don't necessarily need to be changed, assuming that they don't violate any of the other rules. An interface can receive more super interfaces in a binary compatible way. It can't receive classes at all. So that's an obligation for your subclasses to be accounted for, or to pay the price for. Okay. Other questions? Good. And so forwarders, yes, I meant to mention that too. So actually, we did a lot of experimentation here. So forwarders are basically just little method implementations for all the trait methods mixed into the final subclass. Once we know what all the order of method calls should be and what all the super accessors should look like, those forwarders basically override all concrete methods defined in traits. And we don't necessarily have to do that because most of the time it follows what Java resolution would give you. But it turns out having all these overrides there sped up JVM performance, cold startup performance, by a significant factor. Lucas wrote a long blog on that you can find through the release notes or through the pull request. But yeah, it basically comes down to the class hierarchy analysis that the JIT does to figure out where all the method calls are going to go. Is just not, the data structures are not set up to really efficiently deal with pretty deep hierarchies, especially as seen in the Scala collections. So yeah, at the trade-off of bigger bytecode and slightly more brittleness for binary compatibility, we decided to enable them. You can actually disable them in your project if you don't care about startup and you want the other benefits. You can turn it off. It's not needed for correctness. But obviously, we care a lot about performance. So we really went down all the way to the vTune machine code level to figure out what's going on. And anyway, so we're watching this space, and we might flip the switch in 2.13 if the JVM gets better at this. But for now, maybe we'll have a reactive VM or something at some point. I thought that was a funny joke. Anyway, no reactive VM then. That's market tested. Yeah. So having invoke dynamic driven Lambda. It's really easy to summarize. It's basically doing the same thing as Java C does. And that's what Scala C has always done when we can. Let Oracle worry about the VM and the performance and compiling all this bytecode. And that's worked out pretty well for us. And we intend to continue profiting from that. There's basically one major gotcha, and that's because where does the Lambda body go when it goes to the meta machinery that spins up those bodies? Well, it's now in a method in the class that encloses the literal function that you're writing, and so everything that's on the right of the arrow goes into a method at the soonest kind of spot where we can put a method. Before it got spun off to an anonymous class that was a subclass of a function, and usually in Scala, and so, for example, synchronization would happen on the monitor of that object that was an instance of that class. Now, it actually is a monitor of the enclosing class, and if you're already holding that lock and you come back from a different thread, you deadlock. And so we're getting reports that people are surprised in Scala check, for example, when you tend to define lambdas in objects and you spin up a future or something like that, and then you await that future. It used to kind of accidentally work because you weren't locking on yourself when you're calling that function. Now you are, That also means that you will capture the outer pointer if you reference, if you capture stuff from the class, it'll indirect through the dis pointer instead of capturing just that field. So there is a potential for memory leaks, which we've worked to minimize, and we'll continue to improve lambda lift to capture really the minimum amount, but it is a tough trade-off between how many arguments do you want to pass into that method and how much heap do you want to hang on to. So that's one of the things where we need to be careful, and things like spores can help, although the project is needs some more work, I would say. But yeah, this is something that gets very technical, so I don't want to linger on that too much, but I do want to make sure you got that caveat. I think I've said most of that. Wildcards is all I'm going to say. But to give you an example of stuff that now works, you can actually have an overload that takes a function and that takes a SAM type from Java, and you can call it with this beautiful syntax of underscore, this different looking underscore, another underscore, and it'll pick the function one. And that's because whenever you have an expression of a function type, you can pass it to a function or a SAM type because there is a conversion from a function literal to meet its expected type of any SAM type, not just a function and type that Scala knows about as a built-in function. The other way around, when you have an arbitrary expression of a comparator type, you cannot pass it to a function too because it's not a subtype and there is no conversion that goes the other way. This is kind of the intuitive explanation. We had to futz it a little bit to really just slot it in a backwards compatible way. This is kind of the best we can do in the space that we are under the constraints that we have. But so be aware that when you have an overload like this, the function version will be called. But because we're doing type inference for overloaded higher order methods, the same way that DotE is doing it, it actually figures out the types for the 3 examples. And that was another feature that we did to make sure that the migration is smooth. But there is a change there. So I have a quick example for you just to prove that you can. If you wanted to work with streams, this is just in the REPL, and it all works until you hit wildcards. And I spent a lot of time thinking about how to kind of plug this in, and we have some ideas. Jason implemented a plugin to kind of retroactively bestow definition-side variants on a lot of the Java built-in types. Because what you're seeing here is a breakdown of type inference because we don't understand definition-side variants and what it means for the direction that type inference needs to go in when it's following the subtype lattice. So it gives you suboptimal error messages, and it doesn't happen in a lot of the cases. It has to do with really like the perfect storm of overloading and hand-specialized Java methods and wildcards. And there are theoretical things we could do about it, and there are practical things that we are doing about it. It's just not in the mainline compiler. And so the solution here is to actually supply the type argument that we can't infer and that Java can. Yeah. So that's something to be aware of. It's something that you can work around. And if you do a lot of Java interop, it might be useful to investigate that plugin or to have some wrappers where for those API kind of pain points that don't mesh very well with our way of doing type inference. So to conclude, briefly about 2.13, we've been thinking about this for a long time, while the compiler was compiling, for example. And I just want to give you a sense of what we're thinking and what we want to put our team's resources towards and our time towards, and all of our energy. And so it is going to be a library release. That's our TikTok scheme of focusing on one release. We work really hard on the compiler, and then we turn to the library. And I think everybody will agree that the Scala library can use some more work and some more love. And we've talked about that in the past. I dread to click on this link. It's been a while. And we're shooting for a slightly shorter cycle this time because we won't have this parallel tracks going on between like we did for 2.11 and 2.12. So most of all, we want to simplify the collections. And there are kind of 2 areas where we want to do that. There's a lot of common gotchas like seek being mutable by default and things like that are just accidents of history. And that we've never fixed even though we wanted to because of backwards compatibility. But with 2.13, we're gonna make some of those breaking changes, and we'll be very clear, obviously, about what they are. We also want to look into refactoring, and the mantra there is that the community build, which I haven't counted, but is in the single digits of millions of lines of code, our goal is that we should be able to port that to the new design in a week, doing it ourselves. If we can do that, we feel like we're at a point where this is not too breaking, and it has to carry its own weight. Obviously, we're not just going to refactor to feel better about our design. We're refactoring to make you more productive with it. And what I'll say now is that the inheritance hierarchy will change. Parallel collections will be moved to the side. There won't be like all those gen traits. We're thinking about a better split between mutable and immutable, having modules for views, and really just kind of opening up the API a little bit, making it less heavy at the top so that you get less overlap. And so I think I'm confident we'll agree on our goals. We just have to figure out how to do it without breaking everybody's code too horribly. But we also don't want to fall into the trap of never changing anything. We've always acted on deprecation, not as quickly as we always would have liked, but we've always removed deprecated stuff, and we'll continue to do that. And 2.13 will be one of those releases where there's going to be some work, and it's not just going to be cross-build. Like, for example, between 2.11, 2.12, 2.10, and 2.11 was always the goal that you could just basically use almost the same source code, modulo, macros, and all that stuff. And so 2.13 will try to make the impact minimal if you're just using the collections. But if you have been extending them or using some more advanced stuff like breakout, it might not work. Yes, Owen.
Will you provide perhaps a side collection of the old collections so that we can take 2.13 over and then at a slower pace?
Yeah, so that's one of the. So the question is, will there be a parallel universe of the old and the new? And
I mean, like you know how we broke out like Scala XML
yeah.
and that sort of thing, like the Scala old junky collection.
Right. Yeah, for those who like that yeah. So that's definitely one of the things that we've been thinking about. Since the collections are so tightly coupled to the language, and a lot of it, those types appear in the spec, it's a big effort to have like a shared a set of superclasses and between two different implementations of them. Well, yeah, but other people will. So I don't know. I mean, like, I'll be happy to talk about this more offline and in the community, and the process is just starting, and we'll start all this dialogue. Yeah, I like that way of thinking, and it's definitely been come up before in our discussions. We ultimately have to see what we can make happen, honestly. And the more people we get to join in this effort, the more ambitious we can make it. So definitely stay tuned for those announcements, and you're very welcome to join in that effort. So, we don't want to just modularize the collections. There's a lot of stuff in there that I remember from when I was an intern at EPFL that just got in there because no one believed Scala would be this popular. And so it's still there, and that's very often those simple explanations are the right ones, and that's for a lot of the cruft that's in there. It's there because it got in there originally, and no one ever removed it. And for some of these modules, we see a bright future for them. Others, they're kind of being moved to the side so they can gently migrate to the farm, and we'll just not mention them again. There is some stuff in there that I'd rather not talk about in the future, but. You never know how people get attached to weird abstractions that are in there or methods that are crucial for some code base. Is one of the rules is that whenever something is syntactically valid, someone is doing it, and we don't want to be completely stifled by that. And sometimes you have to break stuff to make breakfast, but it's we try to be reasoned about it. Anyway, so my interest is still to simplify the language, and in this case, it means aligning with what's being researched in the DotE incubator. I'm almost there. And so trait parameters are the thing that I would like to see most in 2.13 and that I would like to work on. And we've done a lot of work behind the scenes in 2.12 to clean up the way that fields are handled internally. And so we want to reap those benefits of working on object initialization, better synchronization for lazy files, and trait parameters, and so that we can deprecate early initializers. I hope no one will be too sad about that. But with the Scala Center developing ScalaFix, this is a great time to start being more aggressive in what we can get rid of, and procedure syntax is one of those things that I can honestly say I never wanted. And I'm finally going to have the pleasure of getting rid of it. And similarly, implicits without signatures. So my wish list it basically is everything that's happening in anybody's crazy experiment. And I don't mean to say DotE's crazy, but it's also an experiment. I'd love to see come back to Scala, to mainline Scala. And so I really like the work that they're doing on friendlier error messages, for example. And we'd love to see that come back to the Scala 2 line. Configurable reporting is something that I did some work on internally to clean up the way that we handle reporting warnings and errors. So, for example, you could say anything that's been deprecated for 2 releases, make that an error. Any recent deprecations, I'm OK with that. That's a warning. Something like that. Or don't let me use anything from that package that's deprecated. So being able to configure those things will be super useful. And a lot of those things are just really nice to haves, but not things that I can really motivate spending our team's time on. The Rapel has gotten a lot of attention, a lot of love. Andrew Markey has done a lot of work, and a lot of other people have contributed to making it a nicer experience. And it's one of the key things that sets Scala apart. And with Java 9, they will have a Rapel 2, so we need to be better, quite simply. And I mean, I think we are, but we need to continue improving. And so syntax highlighting, like true syntax highlighting, wrapping that is more amenable to embeddability. So all those big data worksheets are not all of them, but often they are built on the Rapel. Making that easier is definitely one of the goals I would have for my wish list of 2.13 features. Another little evil corporate strategy here is that we want to have your Scala compiler phone home with the version that you're using. But in general, I think it would be a great experience to be able to download one jar ever for the Scala platform and get SBT, get Play, get the Scala Rapel prepackaged with different modules. I'm just throwing it out there. I don't think we'll work on this, but I think there's a lot of benefit to having the SBT launcher being able to launch the Scala console, kind of like what Ammonite is doing with being able to ship with prepackaged dependencies, and just have everything sit in your Ivy cache instead of having to download tars over and over again. ScalaFix, I mentioned already, is a great project under the Scala Center's umbrella that we'd love to use for upgrades to 2.13 and probably will work on. Scala byte is kind of sitting there waiting for someone to show it some love. Makes me sad that we don't have more time to work on it, but ultimately it wants to move all the lint or linting out of the Scala compiler and make it extensible. It's kind of like wart remover, but with a plugin infrastructure. So that's out there in the open. And by open, I mean not for you to see, but for you to change and for you to have opinions about and implement those opinions. So to conclude, again, thank you very much for all the contributions. Thank you to the organizations that are showing how mature our community is. Thank you to Scala Center and the inspiration from DotE. Thank you all for attending. Happy to take questions when I have time. Mr. Pretty.
Adriaan, you mentioned, well, you showed a slide with implicits without signatures.
Yeah.
But you very quickly glossed over it. Could you explain it?
Because I knew you were in the room. I'm just going to talk in the microphone like this now. Just don't do it. I mean, the problem with implicits without signatures is that implicit search and type inference happen at the same time. And when you have to figure out which implicits are in scope while you're inferring the type of an implicit that doesn't have a result type, it just kind of gets into this weird circularity where things start depending on the order of definitions, because we have kind of ways to break those cycles that say, well, these things have been inferred already. I'm here now. So let's see what we have. And that's really not the kind of programming that I would encourage anybody to indulge in. When you have all the types available to you as the implicit search part of type inference, none of that sensitivity to orders of definitions or kind of like caching strategies that we have in the compiler that people take advantage of. I won't name their names, Miles, but I'm sure you've run into them and thought of them as bugs, luckily, but I hope no one thinks of those as features. Yeah, so I think that's kind of what we're thinking about. And in general, any non-private definition, you should really consider having an explicit type on it. It's documentation. It's really cheap insurance for future versions of Scala doing different kinds of type inference. You won't be bitten by weird binary incompatible changes when type inference does something else. It's just a good idea. Yeah, Miles. Yeah, I'm being told I'm out, but I will happily take more questions throughout the day.
Thank you very much, Adriaan. If you want to tweet about this, the hashtag is ScalaE.
Is that the Unicode joint thing, or?
So next talk is in 10 minutes.